we're going to go on and we're going to talk more about piecewise functions. I know you did them in Algebra 1, but we're going to dive into them. Now, a couple of things. One, it says piecewise function. So that means everything we draw will pass a vertical line test. Doesn't say it's a one-to-one piecewise function. Just says it's a piecewise function. So we're going to start off with a linear piecewise function. That means they're going to be lines. I have two lines here, a blue one and a red one. So I'm kind of developing this from the ground up. Basically, this is what's happening. If I were to take this blue line of x minus 3 and graph it, my y-intercept is minus 3, and then I'm going to have a slope of 1. Now, I'm not going to connect these with a line just yet. All right, awesome. The next one says I have a linear function of 1/2 plus 4. Oh, sorry, 1/2 x plus 4. So I'm going to go up to 4. And then I'm going to apply my positive slope of 1/2. Okay, now let's get into it. Remember, f of x is fancy for y. That is why when I wrote my linear function over here, I did not write y equals x minus 3. I already have the y written. Now, these outputs equal certain answers depending on their inputs. And these are my inputs over here. So with my blue function, I only want to input from -3 to 0. So that means I'm going to come over here. I'm going to erase all of these points and up till right there. And I'm going to erase all of these points up till there, right? Because those are the points between -3, -1, -2, -3, and 0. And hopefully if you're paying attention, and you have to, this does not have an equal sign. So that means this last blue dot here on 0 is really going to be open. Okay, my red. My red wants me to only graph the points from 0 to 4. So I'm going to erase all these points because I didn't need them. And I was allowed to go from 0 to 4, but notice it said not really 4. So I'm going to go to, this is 1, 2, 3, 4. So I'm going to erase all these over here. And what do I do at 4? At 4, I put an open circle. Now, if I were to draw the line, that's what this would look like. And this is indeed a function. Remember right here, if I drop the straight line on the y-axis, I do not go through 2 points because that point right here is open. So this line is going to hit the red point, but it's going to go through like a piece of thread going through a needle. That blue right there, it doesn't really have a value there. Now that's one way to do it. It's kind of a long way to do it. Some people just set up the points down here. -3 to 0 is blue. Remember, 0 goes with the red function, so 0, 1, 2, 3, 4 goes here. Now I have to use 4 because I have to know to put an open circle there. So we could just go to a table, right? We could go to our calculator. I mean, I can type in x minus 3, and I can go right to table, and I only need the values when the x is negative 3 to negative 1. So that's negative 6, negative 5, negative 4. And I can come over here and I can write negative 6, negative 5, negative 4. I can go back to my graphing calculator. Once again, go to my table. And I want the points from 0 to 4, 4, 4.5, 5, 5.5, 6. Remember, just be careful that if you are graphing the blue line, 0 will be an open hole, but 0 will be closed on the red line, and 4 will be opened hold on the red line. So now we have the picture, and we want you to get the graph of this piecewise function. Now notice I have it divided into, as best as I could, 3 sections of blue, red, and green. So first off, a function is a y equals. So f function x equals. And then we put our big bracket, because there are going to be 3 equations here, because there are 3 separate colors. So working with the blue color, it is going from, let's see, 1, 2, 3, 4, 5, 6, 7, 8. This seems to be going from negative 8, and I'll tell you why I say seems to be. 1, 2 to negative 2. All right, so that's an equation of a line. So that should be really easy to figure it out. All right, so it's a line, and I'm going to figure out its y-intercept, hopefully by just doing the slope. Now, I'm given 2 points, so I could easily find the equation of the line by using our point-slope equation, but I'm lazy, and let's see. So let's pick a nice point right there. So my slope seems to be 1, 2, 3 over 2. So my slope is 3/2 x. Now, if I were to continue this, will I get a clean y-intercept? 1, 2, 3, 1, 2. Yes, if I were to continue that, my y-intercept would be 1, 2, 3, 4, 5, 6, 7. So this is 3/2 x plus 7. And then we put, sometimes, not everybody does this, but we put a little semicolon there. Or is that a colon? That's why I majored in math. And say that this would be the equation we use should we be given an input of x that is inclusive of negative 8 all the way to negative 2. Now my red line, that's nice and easy. 1, 2, 3, 4. That is the line y equals 4. So I'm 4 from, now here's what I was telling you. Since we put negative 2 in the blue section, we are going to put negative 2 as an open x. And that all goes to 1, 2, looks like it goes to 3. Now, let me just show you. Should somebody on the test have done this? Well, I'm going to have the blue opened at negative 2, and I'm going to have the red closed at negative 2. Yes, you can do that. Both of you are correct. We can't really decipher whose point negative 2 belongs to, the blue or the red. So therefore, as long as we know it's a function and we make our input section reflect so, both of you are right. So I'm going to revert back to what I had in the beginning. And now the last part, the green. Well, we know it's a negative slope, and it goes from 1, 2, 3, but see we included 3 in the red, so this is going to be 3 open, all the way to 4, 5, 6, less than or equal to 6, because this is a colored dot. Now, what is my slope? 1, 2, 1, 1, 2, 1. So my slope is a negative 2x, and if I went backwards, 1, 2, 1, 1, 2, 1, darn it, I don't get a clean slope, but I can figure that out. That's 5, 6, 7, 8, 9. It looks like it's going to be 10, right? Because I go up 2 over 1. So that is 2x plus 10. Voila. Oop, let me put my semicolon colon in there. You don't have to do that. All right. Here's another way we can write it. Same thing. Instead of using that colon, they chose to use the word if. So let's do this. For all values less than 1, we're going to use x squared. So hopefully you were taught how to graph a parabola quickly. You go to the turning point and then you apply the scale. I called them steps. Over 1, up 1. Over 1, up 3. Over 1, up 5. So this was 1a, 3a, 5a, with a being the coefficient of x squared. And since the coefficient of x squared is 1, we just move in our odd steps. We'll go over that some more when we get into our factoring section. So over 1, up 1, over 1, up 1, 2, 3, over 1, up 1, 2, 3, 4, 5. Now, I'm going to leave that, and I know that they only want for x values less than or equal to 1. So I'm going to mirror that over here, right? And I'm just going to hold on to that entire parabola for a second. This is how I would do it. Okay, there's my entire parabola. I want to go to where x is 1, which is right here, and I want this green to be everything less than or equal to 1. So I am going to erase all of that stuff right there, because that's greater than. Notice 1 has a less than or equal to, so that gets a filled hole. So let's do red for this one. If I am between 1 and 2 inclusive, it is the line y equals 3. Well, once again, here is the line y equals 3. But I only want to go up to 1, and that's going to be an open hole. So we're going to do this. We're going to, I can't do an open hole. Okay, that's there. And this goes up to 2. Oh my God, that's so small. Look at that. All right, so I can do that with a pen. All right, at 1, it's going to be an open hole. And then I'm going to go to 2, and I include the number 2. There we go. All right, and the last one, we'll make that blue. If x is greater than 2, then my output is the x. So in other words, I'm going to go to 3, and if I put in 3, my answer is 3. If I put in 4, my answer is 4. If I put in 5, my answer is 5. So it is the line y equals x. And let's put an arrowhead on it. Now let's deal with this section right here. This is going to go down to 2, but it's going to get an open circle. So it passes the function test, because if I were to drop a straight line right here, the straight line would go through this needle eye and would only touch the green. Likewise, if I went over here, it would touch the red, but the blue is a needle eye. All right, we'll leave this one to try in class tomorrow.